Today, we are going to break down one of the most fundamental ideas in all of machine learning, linear regression. Now, I know it sounds a little intimidating, but trust me, at its heart, it's all about using simple lines to make some seriously powerful predictions. Let's dive in. So, how is that even possible? I mean, really, how can a basic straight line, the kind you learned about in high school algebra, actually help us see into the future? Well, that's the big question we're going to tackle. And to make this all feel really concrete, we're going to stick with one single example the whole way through. We're going to try to predict a car's fuel efficiency, its miles per gallon, based on just one thing, how much it weighs. It's the perfect way to see all this in action. All right, first things first. Before you can do anything in machine learning, you need data. It all starts with the information you already have. So here's a little snapshot of our data. On the left, you've got the car's weight. In the world of machine learning, we call this the feature. That's our input. And on the right, you've got the miles per gallon, which we call the label. That's the thing we're trying to predict. Now, this is where it gets interesting. If we just take those numbers and throw them onto a graph, a pattern almost immediately jumps out at you. You can see it, right? As the car's weight goes up, its fuel efficiency, the MPG, tends to go down. And here's the core idea. We can basically summarize that entire relationship, that whole trend, by just drawing one single straight line right through the middle of all those dots. This is what's called a line of best fit. It is the simplest possible model you could imagine. Okay, so we've got a line. Now let's get a little more official and turn that line into our very first actual machine learning model. And this is the official definition. Linear regression is really just the name for the technique we use to find that mathematical relationship between our input, the feature, and our output, the label. It's all about putting a number on that connection. What I love about this is how it shows the flow. We take our one input, our single feature, car weight, we feed it into our model, which is really just that line we drew, and boom, out the other side comes a prediction for our label, the car's MPG. Simple as that. All right, I know what you're probably thinking. Oh no, here comes the math. But hang on, I promise. We're going to make this super easy by connecting it to something you definitely already know. Okay, look on the left, y equals mx plus b. We all had that drilled into our heads in algebra class, right? The equation for a line. Now, look at the machine learning version on the right. See, it's the exact same thing. They just used slightly different letters and moved them around. That's it. Let's just break it down. Y, that little tick mark, means predicted. So that's our predicted MPG. B is what they call the bias, but it's just the y-intercept, where the line hits the vertical axis. W1 is the weight, which is just a fancy word for the slope. And X1 is our feature, the car's weight. So seriously, just remember this. Weight is the slope, bias is the y-intercept. The real magic of machine learning is in this process called training, where the computer looks at all the data and automatically figures out the absolute best values for that weight and bias to draw out the perfect line. So for our car data, after the model did its thing, this is the equation it landed on. The bias, or the starting point, is 34, and the weight it gave to the car's heaviness is negative 4.6. This little equation is our predictive model. So let's use it. What if we have a car that weighs 4,000 pounds? Well, we plug in a 4 for our X1, do the math, and out comes the answer, 15.6 miles per gallon. And just like that, our simple line has given us a useful, specific prediction. Okay, that's pretty cool, but we can do even better. A single feature is a fantastic start, but let's be honest, the real world is a lot more complicated. So let's see how we can give our models some superpowers. I mean, think about it for a second. Is a car's weight really the only thing that affects its gas mileage? Of course not, right? What about the size of its engine or its horsepower? To get a really accurate prediction, we need more information. And this is where our simple model evolves into something really powerful. Real-world models don't just look at one thing. They pull in lots of different features at the same time: horsepower, acceleration, engine size, all of it flowing into the model to create a much richer, much more accurate prediction. And here's the best part. The math doesn't even get that complicated. You just add on a new weight and a new feature for every new piece of information you want to include. Each new feature just gets its own slope, its own little knob to turn that affects the final prediction. So for our car model, we could start adding in things like horsepower, maybe the engine's displacement, how quickly it accelerates, even the number of cylinders it has.
Each one of those would help our models zero in on the true MPG. So we've gone from a few dots on a graph all the way to a multi-feature prediction machine. But let's zoom out. Why is this one simple idea so unbelievably important to understand?
Because what we've just gone through, it's the fundamental building block of so many complex AI systems out there. Think of it like learning the alphabet. This model is like learning A, B, and C. And sure, it's basic, but you can't write a novel or build a massive AI that can recommend movies or translate languages in real time without mastering those basic letters first. The core idea is always the same. Find the important features, give them a weight, and make a prediction.
And that's why this is so critical, especially if you're building products or leading teams that work with AI. Really getting this core concept is the key to truly understanding how these systems think. If you want to go even deeper on this, especially around AI product strategy, I highly recommend checking out the source that inspired today's explainer.
So I'll leave you with this question. Think about your own day. Maybe it's predicting how long your commute will take or what your grocery bill will be. What's one everyday prediction you make that could become way more accurate if you just added a few more weighted features? Thanks for tuning in.